Okay, so I'm gonna share my screen first. Okay, so this is week 30, last week of problem solving session of this course, Probability and Statistic. And I'm Kamna Mishra from IIT Mandi as a TA for this course. And this course is instructed by Professor Sumesh Kumar from IIT Kharagpur. So basically, I have taken some questions regarding the previous classes, uh, which we were unable to solve due to time also, and then there are some important questions like there are so many proofs, so that is also uh, maybe good for your understanding. Regarding the exam point of view, I have no idea how they they are gonna make this exam paper or something like that. So this class I'm basically taking as a revision class so that you will understand, or maybe you can just recall with me. If you have anything to say, you can say right now, or maybe you can write in message, or you can tell me anytime. Or maybe you think I need to focus on very a specific topic that you were unable to understand before. That also you can tell. So we will have a discussion on that. Okay. Okay, so from my point of view, I think the very basic started of this class was started from, I think, the simple questions and the very basic thing regarding the probability, regarding the set, sorry. So, what is disjoint set, and then what is uh, a monotonic sequence, and then various inequalities. So I think that you know already that what is the union in infinite, when it is independent, what will be its intersection when it is not independent, then how we deal with this, and then there is Bayes theorem. So Bayes theorem is very important uh, as far as I know. So yeah. Okay, yeah, sure. So let's say you have okay, so I don't think right now I have questions here. Okay, so Bayes theorem. Firstly, I'm going to write what it is. So Bayes theorem is PIA, and probability of A given BI, and probability of BI divided by summation of A given Bj, where j is from 1 to infinity or any number. If you are taking the finite events, that will be finite, like up to n. And what happens here is that the condition is that these bi's are pairwise disjoint event. Disjoint events, okay. And a is any event, you can say a is any event. So then this is Bayes theorem. But, okay. So if you have any question related to Bayes theorem with you, you can tell me, because I don't have any, so I'm gonna say in Google. What, can you repeat? Okay, you don't know. Okay, so I'm gonna tell you one question, and based on that, you will understand how and where you use Bayes theorem. So this Bayes theorem examples. Let's say I'm gonna take one example. Okay, so yeah, I think this example we can use. So just copy. Okay, so is it visible to you? Yeah, I think so. Okay. Okay. So question is what? A bag one contains four white and six black balls. Okay. So you have bag one, let's say, and it contains four white and six black balls, and bag two, you have it contains four white and three black balls. Okay. This is given. So okay. So, what is given here is that one ball is drawn at random from one of the bags, okay, and it is found to be black. So, in the questions, you use Bayes theorem that firstly something happened, okay. Firstly, something happened, like one event is happened. So, either whether like ball is found to be black or if you deal with like that's another question we can take also. So and the die, and then there are different questions. So basically they will say that one thing happened, okay. So it is kind of conditional probability. So one thing is already happened, then what is the probability that it happened because of this, okay. So the ball we have found is already black, so that we know. So one thing already happened, and then we want to find the probability that it is drawn from backward. So basically we say this is as prior probability or prior event. So prior event means that happened already, and then this one is posterior, okay. So this one we say as posterior probability, and this one we say as prior probability. Okay. So now, firstly, what we do is that firstly we find this one ball is drawn at random from the bags, and it is found to be black. Okay. So firstly we find this event. Okay. So if ball is black, then what it means? Uh, it is not given that choosing this bag or this bag, like we are choosing this bag three times out of four and this bag one out of four. It is not given. Okay. So when it is not given, what we consider is that the probability of choosing any bag is equal. Okay. So probability of choosing any bag will be what? 1 by 2, because there are two bags. So if there would be three bags or four bags, then we say it is 1 by 3 or 1 by 4 according to that. So firstly this is probability of choosing bag. So now what will be the probability? So firstly we find prior probability, and then with the help of this we find the posterior one. So prior probability means it is found to be black. So probability that ball is black, okay. We are not saying it is coming from first or second. So we are just saying probability that ball is black. So ball will be black when if we are choosing the first bag, then it will be black. So probability will be 6 by 10, right? Because 6 black balls are there and total are 10. Now, if we are choosing the second bag, it is 1 by 2 and then 3 by 7, right? So now you can do the calculation. It would be I think 7, 10, 140, maybe, no, I think 1070 would come, right? So it would be 6 times 7, 42, and it would be 3 times 10, 30. Okay, so most probably it is 72 by 70. So that would be, I think, 36 by 35, right? So this is the probability that ball is black. So this probability we say as prior probability. Now what the question is, find the probability that it was drawn from bag 1. So this is the probability that this is drawn from any bag, right? So probability that it is a ball, uh, sorry, that black ball is drawn from bag 1. So do you want to give it a try how we can find it? Like, this is for total, so what will be the probability that it is drawn from bag 1? Like, we will use Bayes theorem here. So what we have done in the Bayes theorem, below we are taking all the probabilities. This is nothing but the sum, right? So probability, uh, uh, like first one and then second one and then third one overall, and then in the above we are taking when it is coming from bag 1. So now can you tell me the summation will come in the denominator, and then in the numerator, in numerator it would be this and multiply by 1 by 2. No, okay. Okay, let me clear this again. This is the probability when it is coming from bag 1. This is the probability when it is coming from bag 2. Okay, so probability that it is so black we already know. So we want to find it is coming from bag 1, given it is black. So what we do is that, okay, so you know this basically by the intersection. So probability that it is coming from bag 1 divided by it is black, divided nahi, sorry, it is conditional. So in the below we see the probability that ball is black, and in the above what we do is that we take the intersection, right? So we take the intersection, so bag 1 and it is black. So bag 1 and it is black means, so yeah, 3 upon 10. So this one will come in the uh, numerator. So ball is black and it is coming from the bag 1. This will be 3 upon 10, and in the below we have already found ball is black, so it was 35 by 36, right? And then you can do the multiplication there. So it would be 36 into 3 divided by 10 times 35, and then you can find the answer, right? So I think it's clear now, is it? Okay, so now we can, like, you can have like this type of questions only, I think, uh, Bayes theorem. Okay, so firstly you will have given one condition that this is happened already, and then you need to find if this has happened already, what will be the probability that this event is happened because of this particular region, right? And okay, so now the next thing is that independent event. So I think you know that if you have A and B independent, then probability of A and B is this, right? So for independent events, there for independent events, what happens is that one is not dependent on other. So probability of happening the intersection is the multiplication. And then if you take in place of probability, if you take expectation of two events, then also it will be same. If you take fxy, let's say joint events xy, then also it would be fx x fy y. So basically, it will always be in the multiplication. So whenever you will see this independent, that a and b or x and y or any two events or random variables are independent, then you can say this is nothing but like probability density. So this is probability, and when you are considering random variable, it will be density function. It will come as function. So you always like do the multiplication thing. Okay. uh, Now the next is, I think this one is PDF. So I don't think there is anything to explain in here. The just I can write. So there are two types of, basically we divide in two types. One is discrete and other one is continuous. So for the discrete one, it is probability mass function. So for the discrete, we use probability mass function because at one point there are like several points where is some probability, and then they have some mass, and then in time of continuous, we say it uh, probability density function. And then at one point, this probability density function is zero. So if you have a single point, then it would be zero. Probability at that point would be zero, right? And okay, so this is okay, I think. And then we have, let's say, expectation. So expectation of x, where x is any random variable. So if we have PMF, like discrete one, okay, let me write it like this: discrete and continuous. Right. So for discrete, for continuous. So here we have PMF, here we have PDF, and the next thing is that in this, for fx we do this summation of fx, right? And here we do this integration, so minus infinity to x fx or f at t dt, because x would come in the integration only. And then expectation is, so expectation of x we find by summation, so summation xi. And you can write pxi or fxi, here also it's I. Okay. And here expectation of x is nothing but the integration minus infinity to infinity x fx x dx, right? So Here also you can write x in x, there is no issue. It just we are taking the limit also in x, so it can be a little bit confusing. That's why I am writing this as t. Okay. Now you can have different movements. So if I will go through each and every point, it would not be possible to complete in 2 hour class. So I'm just dealing with the main things that are important for you. Okay. So now there is one thing that you need to remember, that expectation of x uh, does not need to be need to exist always. Okay. So if you have questions like this, whether it exists always or not, so it does not need to exist always. It can exist or it may not exist. But if you have, let's say, expectation of x square is existing, then expectation of x will also exist. And then I think there is moment generating function. So mgf, moment generating function is what? Mxt, and in place of expectation of x, it is expectation of e to the power dx, right? So this mgf is uniquely determines a cdf, and this is unique. Okay. So if you have one CDF, if you have one cumulative density function, then its CDF exists. If exists, then it would be unique. Okay. Now next thing from which questions can come, it's Chebyshev's inequality. Inequality. Right. So what is this? If you have any x random variable with the mean mu and this sigma square, then for any k greater than 0, the probability that x minus mu is greater than or equal to k is less than or equal to sigma square by k square. What it means is that, let's say you have any random variable. Okay, so I have not written the questions for this, but I'm going to tell you. Let's say the yeah, let's say you have a bulb. Okay, and life of a bulb, let's say mean life of a bulb is uh, let's say 2 years. Okay, so it is 2 year, and then standard deviation of it is or yeah, standard deviation, let's say, is zero point 0.5 years. Okay, so zero point 0.5 years, and you want to find that what is the probability, that bulb, uh, like for a specific bulb we are saying its life will be in between 1.5 to 2.5 years, right? So whenever you see question like this, if you have mean, then it would be deviated like equally. This is 1.5 to 2.5. Okay, because here k, because here what we are doing is this, this is mod, so it would be x would be in between minus k plus mu to k plus mu, right? So now you know probability of x minus mu greater than or equal to k is less than or equal to sigma square upon k square. Okay, so this is x minus mu greater than or equal to k, but we want to find in between, so there is a less than inequality, right? So if you have greater than is greater than 1 minus sigma square by k square, so for negative what we do is that we will have 1 minus probability for less than, it would be x minus mu less than or equal to k would be less than or equal to sigma square upon k square, right? So if you take this here and this here, so it would be ultimately end up x minus mu less than or equal to k would be greater than or equal to 1 minus sigma square upon k square, right? So now you know everything is given. You have x minus mu given is 2 and it is less than or equal to point 0.5. How I have find this point 0.5? This one would be because here it would be probability x is coming from minus k plus mu to k plus mu, right? So we want to find it is from 1.5 to 2.5, right? And mu is 2. So if you take this as minus k plus 2 is equal to 1.5, k would be zero point 0.5. Okay. So if you have any confusion, let me know, because I have told this very fast speed, I think. Okay. And if not, then you want to find this thing. Basically you want to find this thing and then you can write it like this, and now you know its probability is the minimum probability is 1 minus uh, this sigma square. Now we know what is sigma, zero point 0.5. So sigma square would be, I have written, yes, sigma square would be 0.25, and then k square would be k is also zero point 0.5 we are taking here, so that would also be 0.25. So it is greater than or equal to 1, that means it would be 1 simply, right? So in this kind of question, you can use Chebyshev inequality. So basically, what will be given to you? You will be given to you this mean life, and then the standard deviation, and the question will be, it may happen. It will ask like this in between 1.5 to 2.5 years, or it may also happen. The question would be like the birth life is. Minimum 1.5 year and maximum 2.5. So minimum 1.5 means x is like minimum 1.5 and maximum 2.5. So that equation will come in this way, right? So when you will practice, you will know in better, but I hope you have understood by this. So if you have any question in the middle, you can just ask, unmute yourself. Okay. Now, there is another thing, Markov's inequality. So this is not, we use it less if you compare with Chebyshev's, but then still I'm gonna write this gx g. So and then g given here is that g be a non-negative and non-decreasing function of Rx. Okay. Okay. So next we have discrete distributions. So I cannot go through all the distributions right now. That is too much. So I'm just telling you there are Bernoulli and then binomial. So you need to know this expectation, mean, and variance, and then if possible, moment generating function also. So and then we have Poisson process. So Poisson is, I think, very important. So that that you need to recall. And then we have continuous distribution. So continuous distribution also the same. So you need to remember the PDF firstly. So PDF and CDF, because in sometimes we don't, if we forget this PDF CDF of very I think a common distribution, very simple, like uniform distribution. You know the PDF is 1 upon b minus a, right? So 1 upon b minus a if you have continuous uniform distribution. But then CDF sometimes people forget, so then you also need to remember this. So it would be t minus a divided by b minus a. Or if you know how to solve this, then also you can do that just by taking this integration. You can solve it minus infinity to x. Yeah, I think I should write it in x way. So and then you have exponential distribution. So exponential and gamma distribution, variable distribution, like there are a lot many, very long list. And then you have reliability parameter, reliability of series of parallel. So in the time of a series system, you have reliability like is given by rxt is probability uh, x1 greater than t, like series and parallel, you know, right? So if you have n components and these are located like this, then if you have this one system probability that let's say this is its reliability is zero point 0.9 and its reliability is zero point 0.7 and it's zero point 0.8, right? So in the series you just do the multiplication. Okay, so I should just write this like this. So by I, so in the series you do the multiplication like this. And for the parallel, so parallel means one is not affecting other, right? So in the parallel you have rxt as 1 minus summation 1 minus pxi greater than t. Okay, so these are just formulae you need to go through the whole. And then there is beta distribution. And of course the most common one used is normal distribution. So for the normal distribution you need to understand it with like we have used it also too much. So it you need to remember it. And then normal distributions to standard normal distribution, standard normal variate. Next, is questions based on that basically, and then you will have functions of a random variable. So that one question we can do from here, like if you have let's say one random variable is given, let's say it is normal random variate, and then you have a pdf given like this. Of course, for normal random variate it is 1 upon under root 2 pi, and the sigma is 1. It will not come. E to the power minus x square upon 2, right? And x is in between minus infinity to infinity. And now I want to find y is equal to x square, and I want to find the PDF of this y. Then how I can find it? So uh, the basic thing is that we do the conversion. So firstly, and then here when you will have two variables, then we find the Jacobian basically means differentiation over more than one variable, but here we have like one independent and one dependent variable, you can say like this. Then we do this differentiation. So uh, okay. So what we do is that we find this firstly y is equal to x squared. So we find the function. So we say g of this is equal to y. So y. So x is equal to basically plus minus under root y, right? So this we take as write it as function. So we say g1 y is equal to root y because there are two functions. So and then g2 inverse y is equal to minus root y, right? So these are two functions so that you can find directly, and then what we do is that we take the differentiation of each. So what would be if its differentiation? It would be like d of this would be 1 upon 2 root y, and for this it would be minus 1 upon 2 root y. There is entry or some question. Okay, okay, right. So this you have fine, and then the fy is nothing but its summation. So it's summation. So over, and then you we take this positive value. So it would be 2 upon 2 root y, and then we write this term in terms of y. So it would be 1 upon root 2 pi e to the power minus y upon 2. So it would be 1 upon root 2 pi e to the power minus y upon 2. So summation I have done earlier. So now at end it would be 1 upon root y under root 2 pi e to the power minus y upon 2, and then here there is under root, so y need to be this. And anyway, if you see from here also, so x is minus infinity to infinity, so y would be from 0 to infinity. So that is the PDF of y. So this is how you can find the PDF of y if you have one random variable is given. So one is given and another one you want to find. So this is the way to find this. Okay. And if you want to have formula for this, you can write f of y is summation f uh, xky means we are writing this pdf, the pdf of x in terms of y. So we have written the pdf of x in terms of y, so we there is just x squared, so we are putting y here. And then it's multiplication with mod of uh, g dash xky, right? So this was g dash. So its summation would be mod will be 1 upon root 2 y plus 1 upon root 2 y. So this is I have written 2 upon 2 root y. So this is how you can do uh, the transformation if one variable is given and you want to do the transformation per second. Next we have I think joint distribution function. So joint distribution function is very it can be a little bit confusing. At least it was confusing to me in the starting. So that you need to remember always what are the limits you need to put. Okay. So I think I will do one question, and in that, just give your whole attention so that you will understand how we are doing this. Okay. So, joint density functions. Right. So, for the joint density function, let's say I have one given here as 10xy is square 0 and 0x less y less s, and then this one is s, right? So firstly, there are, let's say, so many things to find. We need to find the marginal of x. This is called marginal of x, this is called marginal of y, this is called the joint density function of fx and y. So I will find it for x and you will find it for y right here. And then let's say f of x y is equal to y, x given y. And then let's say f of y is x is equal to x, right? Y given x. And then we have this thing 0 x plus y 1 by 2. So I'm taking all these questions from the class itself, so when you will go through it you will see, because I have not made the questions specifically for this, right? So and then we can take one more. Let's say 0 to x 1 by 2 and 1 by 4 to y 3 by 4, right? So now, so marginal of x, these are marginal, these are conditional, and this is some probability we need to find. And then this one is nothing but this will come under the conditional one, right? Because y is given, and then you want to find this, and the last one is for separate x and y. So here fxy is given. So how do we find the marginal of x? So for finding the marginal of x, you always do the uh, integration for y, because at the end we want to find this like fxx. So we want to find the density in terms of x. So we do the differentiation of y, and then we will put the limit of y here. So what is the limit of y? So limit of y is x to 1, right? You cannot take it from 0 to 1, otherwise it would be like less than x also sometimes. So for y it would be x to 1, for x it would be 0 to y, right? So it would be x to 1, and then it is very easy, it is 10x, and then y square would be y cube upon 3. So y cube upon 3, I'm taking 1 outside, and then it would be 1 minus x cube, right? And then now once you have found for x, now there is no y, so you will write it as 0 x 1, right? So this PDF would be 0 to x to 1 and 0 else. So now I want you to find fy of y. It what would be fy of y? So this is the thing, and calculate it. It will not take a lot of time. So for y, we do dx, and the limits will be from the variable. If we are doing for dx, then a limit would come for the x itself, right? Hmm. Yes, limit would be from 0 to y. Yes, it would be 5 to the power 4, right? So now you have understood this marginal. Next, we will go through this conditional, right? So for the conditional, that's you have found already 5 to the power 4, and then 0 to by 1 0 else. Now the conditional one, let's say x y is equal to y. So conditional one is what? In the below you have this marginal, and in the above you have this uh, medium joint, because conditional is nothing but what? In the division you have whole, in the upper you have the intersection. So joint is nothing but the intersection kind of thing, right? So you have, fy, it was 5y to the power 4, and fxy, it was 10x y square. So it would be uh, 2x upon y square. So in that way you can find for fy also, fy given x is equal to x. So that would be fxy divided by fxx, right? Okay. So next question we have here is that probability of x plus y is in between 0 to 1 by 2. So now you need to do let's see, I'm writing here. I'm gonna write this here. So that we need to find probability of x plus y 1 by 2. So for this, if you have any time probability like this, then you need to find the area firstly. Which area is coming in this region, right? So firstly we will say that that is it is defined in which region, okay? So uh, it is defined where, so you have y greater than x, so whenever you have things like this, just make it equal, okay? So y is equal to x, firstly we will make this line y is equal to x, right? And then y is greater than x, So at this point y is less than x. You can take the values if you have any confusion, but otherwise I'm telling you this is the region where y is greater than x, right? And y is less than 1, so up to this it would come, right? Let's this is 1, let's say, and this is 0. So this is the region where PDF is defined. So x is 0, and then this y is the maximum, and then this one is also 1, right? Now we want to find 0 x plus y less than 1 by 2. So in the class also I have told you how we find this. So 0 greater than 0, that means it would lie here. Now the thing, this x plus y. So firstly you convert this inequality in equation, right? And now to draw this equation, the best form always is intercept form. So intercept form is x divided by 1 by 2 plus y divided by 1 by 2 is equal to 1. So this is the intercept of x and y axis, right? So you will have 1 by 2 here, you will have 1 by 2 here. This would be the, let's say this 1 by 2, this is that, right? So this is x plus 1 y. And then for less than 1 by 2, so this would be 1 by 2. The below one would be less than 1 by 2. So this will come. And the PDF is defined only here. So this would be the region where we need to find the probability. Understood? Okay. Thank you. So now how do we find the probability? So you need to know where the, like x and y, where it is changing. Okay. So if you have 0 to up to here, then uh, this one is firstly we need to find this intercept point. Okay, so this is y is equal to x, this is x plus y is equal to 1 by 2. So if you take y is equal to x, it would be 2x 1 by 2, so it would be 1 by 4 comma 1 by 4, right? Now this we find y using a joint, right? Joint distribution, because x and y both are involved here. So if how do we find it? This one is for y. So if you have x from 0 to 1 by 4, right? X from 0 to 1 by 4, you have this y and this y. So I think you can write it directly. So x is from 0 to 1 by 4, and y is, the below line is x and the above line is y is equal to 1 by 2 minus x, right? So when x is in between 0 to 1 by 4, the y is in between the below line, y is equal to x, and this one is uh, 1 by 2 minus x, right? So the integration would be 0 to 1 by, okay, okay. Just let me just write it and then I'm repeat. So we need to find this area, right? To find this area, what we can do is that we need to have the limit of x and then we need to have limit of y. So the limit of y would be either independent of x or either dependent of x, because once we do this integration and then you have terms in, sorry, if you have limits in terms of x, then you will have values in terms of x, and then we do the integration over x. So this we need to find what is this region. So how do we find it? We take 0 to 1 by 4 x, right? X is from 0 to 1 by 4, after that it is not. And then for y we take the below function and the above one. So the below line and the above line. So if we take this below line is what? This is y is equal to x. So limit, so the limit would be y is equal to x, right? So you will know this, these are the limit of y, and the above one is what? Y is equal to 1 by 2 minus x, because it is the line of x plus y is equal to 1 by 2, right? So y would be 1 by 2 minus x from here. So y would be 1 by 2 minus x. So these are the limit of y, and the limit of x we already know, it is 0 to 1 by. Is it okay now? Yes. Then you need to take the limits of y firstly, right? So what you will do is that y is equal to 0, and then the above one, how you will take it, you need to cut it, right, because here y is equal to 0, and then here y is equal to x. So y is equal to 0 to x at that point. Then sorry, uh, y would be 0, and then no, sorry, this one is the limit of x, right? So x would be 0 to y, and then y here would be x is 0 to y, and y here is 0 to 1 by 4. So y, right, and then plus when y is from 1 by 4 to 1 by 2, the x would be what? The x is again 0, and then it would be 1 by 2 minus uh, no, see, x is from 0 itself, no? This one is 0, and this one is 1 by 2 minus y. Is it still confusing? Okay. No? Okay. So you can write, do in either way. So in this way, you need to do just one integration. In this, you need to do two integration. Then it's also fine. The, anyway, whichever way you are comfortable, do it in this way, in that way. Okay. It does not matter how you are finding this. Like the answer would be same if you take the x limit first or y limit first. That does not matter at all at the end. Okay. So now you have this simple integration that you can do. This is 10xy square, and then you have it's in terms of x. That means you are doing differentiation in terms of y firstly, and then you have dx here, right? So that you can solve. Now the next is this. So x less than 1 by 2, and y is equal to 3 by 4. So now what you need to do is that probability of x less than 1 by 2 given y is equal to 3 by 4. So this is nothing but probability like fx given y is equal to y, right? So that we have find fx given y is equal to y. So that is what? 2x by y square, right? So fx given y is equal to 3 by 4 is nothing but 2x by y square, and then y given here is 3 by 4. So 3 by 4 is square, and then it would be uh, just you need to multiply, I think 4 16, and then it would be 32x, and in the below it is 9, right? Now you need to find x when x is less than half. So when x is less than half, then it would be 0 to half 32x upon 9 dx. And now you can do the integration. 32 upon 9, this is x square upon 2, so x square is 1 by 4, and then it is, I think, 8, 8 4 times, so it was 4 by 9, right? So if you have anything given like this, you need to understand this is for the from the conditional. So once you have find the conditional distribution, you can put the value of y here, because y is equal to y we take in the conditional, so you can put the value of y here, and then you have this distribution, and then in place of x, now you can take 0 to 1 by 2 or whatsoever limit is given there. Okay. Okay, I think. And then last we have uh, this question: x is in between 0 to half and y is in between 1 by 4 to 3 by 4. So now again we need to find the area, right? So, sorry, I'll do this below. So this is the place where above PDF is defined, where y is equal to x is this line, this is 1, this is 0, and because y is greater than x, so this is defined here. And the question is that we need to find the probability 0 to 1 by 2x, and y is from 1 by 4 to 3 by 4. Okay, so y x is from 0 to 1 by 2, right? So x is from 0 to 1 by 2. So let's say this is 1 by 2. So x is from 0 to 1 by 2, and y is from 1 by 4 to 3 by 4. So this is obviously 1 by 2. When x is 1 by 2, y is 1 by 2. So this must be 3 by 4. Then this we can take as 1 by 4, right? So 1 by 4, 3 by 4. Okay. Now x is in between 0 to half, y is in between 0 to 3 by 4, and the PDF is defined over there. So this is for x, this is for y. PDF is defined over here. So this would be our region, right? So it is very important to find the region firstly. Okay, nothing else. Now, now we can do the limit again, and then again it's dependent on you how you want to do. So this is 1 by 4, so this would also be 1 by 4, and this is 1 by 2, so this would also be 1 by 2, and this is 3 by 4. Okay, so now you can take 0 to 1 by 4 x. Then if you take 0 to 1 by 4, y would be what? Y would be 0, and then in the above, y is 0, x is in between 0 to 1 by 4, then y would be is in between 0 to x. Okay, x is 0 to 1 by 4. Yeah. Y is 1 by 4 to 3 by 4. Sorry. Yes. Yes. Huh. Yes, yeah, I think that's the best way you can do this. So this it would be more complex. So yes, so the best way you can do this would be area of a square would be nothing but this is 1/2, I think, and then this is 1/4, 3/4. So this would also be 1/2. Of course, this is a square, so this is 1/4, and then you can subtract this triangular area. So this triangular area would be nothing but uh, 1/2. I think this is uh, the base here is 1/2 minus 1/4. So this one is 1/4, and this one is also 1/4, right? So it is 1/2 base into height, right? So 1/2, 1/2. So I think 1/2 to 8. So that you can find. I think 1/8 would be the answer. Yeah, this is the best way. But anyway, yeah, right. And then if you want to do in that way, that is also you can do. Okay. Now, the meaning here is that you need to understand how to do that, like find the region and then solve it. Okay. So this is, I think, from joint PDF, and okay, conditional case. How we find the conditional case, or how I have done this one. Okay, okay, okay. So for the conditional one, so the first thing you need to understand is this, how the question is given. So if you have question like this, so now you know x, there is something on the x is given, so that you can find with the integration of x, and given here is y is equal to 3/4. So given thing is y is equal to y. So now you can also write it in this way. You can write probability of some x. Okay, something condition is given y is equal to y. Now this comes under the conditional one. So the conditional probability we have already found. So that would be sorry. Now, to find this conditional, what we do is that firstly we find this conditional distribution when y is equal to y. So, conditional distribution we already know what is fx y is equal to y. So, here only we need to put y is equal to y value. So, that's what I have done here. Fx y is equal to y, and y is equal to 3/4 is given in our question. So, the this one is 2x by y square, so it would be 2x divided by 3/4 square. Okay, and then it would be 32 by 9x if you solve it. Okay, so this is the PDF. Now once you know the PDF, how do you find it? You find it by doing the integration. So doing the integration means x is less than half, so it would be from 0 to half, and then 32 x by 9 dx. So now you can do the integration, and that would be your answer. Is it okay? Okay. So the next thing you have from the joint distribution is bivariate normal distribution, and then I'm not going through all this. Uh, okay, so that, because that is just the theoretical part, and yes, there are two, three things that you need to remember. That if you have, let's say, if you have xi following the normal distribution, then what we know is that summation xi, if you have xi, let's say, normal mu sigma square. right? Then its summation also is normal distribution, and that normal distribution is nothing but uh, this summation over mu and then over sigma squared by n, right? So uh, that you need to know that if there is xi, then what its summation xi follows. Okay, because like for the normal one it is true, but for like exponential, let's say x1 x2 up to xk, let's say xi follows exponential lambda. Okay, and I is, let's say, from 1 to up to k, then summation xi follows, uh, let's say y is equal to xi I'm taking, then it follows uh, gamma distribution. Okay, so it does not follow this exponential distribution, right? And then so this is, I think, and then we have already done the join PDFs. So this is okay. I don't think there is anything to repeat here. Okay. Now the next, we say that it is very important, which is a central limit theorem. Okay. So central limit theorem. So the central limit theorem is what? If you have xi is the sequence of, let's say xi is a sequence of independently and identically random distributed, sorry, independent and identically distributed random variable with, uh, let's say, mean mu and variance sigma squared, which is less than infinity, that means finite variance, and let's say x bar is summation xi 1 upon n. Then the limiting distribution of root n x bar minus mu by sigma, and that also we write x bar minus mu divided by sigma upon root n is normal, standard, variate 0 to 1. So that is central limit theorem, and with the help of this I think we solve like several number of questions by taking this as a standard normal variate, and then we find the probability of, like, standard normal variate is what, z. So then we find the probability of z with the help of z table. So in the time of hypothesis testing or many things, we use this standard normal. So this is the central limit theorem, which is very important, I think, and you need to remember. And if you this is for what, this is for x bar, and if you have for summation xi not divided by n, just summation xi, and let's say you are denoting it by s, which is summation, then it's s minus n mu, and it is root and sigma. So just we are multiplicating everything by n, right? So if you multiplicate this by n, then sigma upon root n would be root n sigma, and it would be n mu, and root n x bar would be x, I think xi you have. in the above. If you multiply everything by n, then it also follows normal 0 1. So if you are solving with respect to summation xi, then you need to take n mu and root n sigma. And if you are solving with respect to x bar, expectation of x or mean of x, then you need to solve it by mu and sigma upon root n, right? So the standard, like making your variate standard, would be change. The parameter would be change. Okay, and then there is chi-square distribution. So that I think I have already told you, but still. So if you have the PDF, you can see what is the PDF, and basically, if you have uh, x, let's say follows normal 0 1, right? Then y is equal to x square. We have solved earlier, I think, and we can also see what it came, right? So where is this? Yes. So this. Oh my God, why it is happening? Okay. So this is, we can write it in this way. Uh, let it is equal. Okay. So 1 upon 2 to the power half, and then for pi we can write gamma half, under root pi is gamma half, and then e to the power minus y by 2, and then under root y we can write it as y to the power 1 by 2 minus 1, right? So I'm writing this thing only in this way, and then this is nothing but chi square distribution at 1. Okay, so chi is square distribution. How we define chi square? So chi square is defined basically, its PDF is defined basically, let's say f is defined like 1 upon 2 to the power n by 2 gamma n by 2 uh, e to the power minus, let's say w is the variable, and then w to the power n by 2 minus 1, right? So if you see by this and this, so you can see e to the power minus y by 2, y to the power 1 by 2 minus 1, and 2 to the power 1 by 2 gamma 1 by 2. So this is chi-square distribution. So if you have f x is your standard normal variate and y is equal to x square, then y is nothing but the chi-square distribution. So if you have x is normal variate, then this x square, if you have x as normal variate, then this x square follows chi-square distribution. Okay, this is, I think, chi-square distribution. And then hypergeometric, and then there is t distribution. So t distribution is also came from this standard normal variate. Okay, so if you have, let's say, x is normal distribution 0 1, and y is chi-square distribution with n degree of freedom, then uh, t is what? T is x upon root y upon, so basically root n x and divided by root y. So this is t distribution. Okay, so t distribution, and then there is f distribution. So f distribution, like basically these are like, if you have one random variable following this distribution and second random variable following this distribution, then how do we find the distribution when it is, let's say, dividing or dividing with under root? So there are like, there can be like, I think infinite number of functions we can make over this. Okay, so if you have x and y like this, then we can make x plus y, and then we can make x by root y and x by y. There are like in infinite way to find the new functions, but then there are some standard function. So these standard functions we define in this way. So t distribution we define in this way, and then chi square, like x square, we say as chi square. So then we give it a name, right? And like this, we give the name, if y1 and y2, let's say chi square, m and n. Then if you have this random variate, have u is equal to this, then if you have this u is equal to n upon m, y1 by y2, then we say this as f distribution. So again, there can be like thousand many, but then these are some standard form that you need to remember. What is uh, chi-square distribution, what is t distribution, what is f distribution. Okay. Okay, I think so. This one is up to the probability part, and the next we have the statistic parts. So for the statistic, now the very basic thing that you can do on your own is arithmetic mean, and then geometric mean, and then mean, median, mode. How we can find it, mean, median, mode in the continuous data or in this discrete data. So for the discrete one, we use by just like median, we find by just putting the numbers in increasing or decreasing order and then taking the mid value or something like that. If you have class, then there is another rule, so that I have told earlier. So then you can go through the lectures. And but for the continuous one, what we do is that we take the integration and then put the value is equal to half. So the point it has covered half of its area, that point would be the median, right? So uh, next we have estimation. So there are two types of estimation. One is point estimation and another one is interval estimation. So the point means exact, we want the exact value, and with the interval, that means there is confidence interval. Confidence interval is basically meaning we are allowing some error, because in the real life we cannot say if this happened exactly. Like I'm saying, this is the population, I have like 1 lakh population and 1000, let's say, sample size, or 10,000 sample size. Then also it will not happen that mean is exactly same. It will never happen, I think. So then we allow some kind of confidence interval. And then if the mean lies in between this, let's say, uh, uh, for the whole, I think, let's say for the Delhi University, you are taking the numbers, okay, and then on an average, you are saying this mean is 90. Then you cannot expect to take this just one class and expect it to, or maybe some random samples. Let's say there are 20,000 student in one university, and you are taking this 1,000. Then its mean would be different, but then it should be, if it is coming under some confidence interval, let's say it is coming under 85 to 95, this one is my allowance, I'm permitting this kind of error. Then it will depend. If it is coming under 85 to 95, then we will accept it as a good sample. So, interval estimation is always the better option when it comes to the real life. And now, to find these estimators, there are many methods. So, there is a method of least square estimation. So, what we do is that we find the least square, as the name suggested, just by taking the square summation of the error and minimizing it. uh, and then method of movements, and the most important one is maximum likelihood estimation. So this is the most important, I think. And yes. Okay. Okay, yes, we can have some problem on Emily. So let's say, okay, I'm finding the question. Give it a minute. Okay, so this is the basic one. Let's say we can do, let's say xi, we have xi's, which follows this Bernoulli distribution over 1 comma p, right? And then we want to find the MLE. So finding the MLE, the method requires is what? Firstly, you need to find the L. L is what? Summation fxi, fxi and theta whatsoever with the parameter. So theta, let's say. Okay. So here the parameter is p, and then you have a log L, which we denote by L. So this we do just to make our calculation simple, because uh, L log L is an increasing function. So when L is increasing, log L is increasing, and otherwise. So it will it will decrease. So it will also decrease. So then we find log L, and then we find del L by del theta. We make it equal to 0. Maximum likelihood means we are finding the point where it is given the maximum function. So maximum it will give, firstly it is equal to 0, then you have some values for theta, and then we say if del 2L del theta 2 is less than 0 at that point, then we say this is MLE, right? So let's say this is the question. So first thing we need to find L. So L would be, it's Bernoulli. So Bernoulli, you have p 1 minus p, okay, and over x, p to the power x 1 minus p to the power x. So it would be pxi 1 minus pxi, and then multiplication of it. So pdf. So this is uh, multiplication fxi theta, right? And then uh, when it is a multiplication, so it is px1. So it is px1 px2. So it is nothing but p of x1 plus x2, right? So its power, gives the summation. So then we can write summation xi, and then 1 minus p, this is summation xi, right? Now we find a small l. So a small l would be log of this. So log of this would be what? Summation xi log p plus, sorry, it is 1 minus xi. So it would be 1, 1 will add, then it would be n minus xi, right? So, and then it would be n minus summation xi log of 1 minus p, right? So now we find del L by del theta. So theta here is P. So it would be summation xi divided by P, and then plus n minus summation xi divided by 1 minus P. And for 1 minus P, 1 is 0, minus P is minus 1. Right? Now the next step we do here is we make del L by del P is equal to 0. So this one and this one would come in equality. So summation xi by P is equal to n minus summation xi divided by 1 minus P. Now we can do the multiplication. So summation xi minus P summation xi would be equal to P n minus P summation xi, right? So this one would be cancel out, and P would be summation xi by n, right? So this is our P. Now uh, generally we just say that this is the MLE, but it is a good thing to check this also, because we need to find the maximum one overall. So now you can find the del 2 L by del P2. It would be what? It would be summation xi by P would be minus summation xi by P square, and for this it would be minus n minus summation xi, and 1 minus P would be 1 minus P square, right? So firstly, 1 minus P would be 1 minus 1 minus P square, and then 1 minus P would be again minus, and there was 1 minus over there, so it is negative. Now you can see P is what? Summation xi over n. So you can put the value here, either by summation xi, you can just put Pn, right? So it is Pn by P square minus n minus Pn by 1 minus P square. So this value is positive always. N minus Pn. P is less than 1, that we know, right? So n minus Pn is positive. So this whole value is negative, and this value is negative. So this overall summation is a, oh my god, what's happening? Okay, yeah, less than 0. It's not responding. I need to wait for a minute. Yeah. So that would be less than 0. So now del 12 del theta is less than 0. So now we know that this is MLE, right? Okay, but still, I recommend you to go through the lectures, because then there would be a thing that when the MLE could not answer it in the result, because sometimes it may happen that del L del theta, putting it equal to 0 is not giving the required result, or it may also happen like we are unable to solve this del L by del theta, right? Because here it is coming like a very easy way, so we have solved P in terms of other, but it may also happen that P is like coming, let's say, in square itself, and then let's say P square plus P minus this, then it is very difficult sometimes to solve this. Then if not, then we may go through the other things also, so that you need to see. Like, I cannot go through the each and every exception here, so that you need to go through. Okay. And then there is a method, uh, different methods to find. Okay, yeah, I have missed this point, I think. So there is unbiased estimator, there is consistent estimator, unbiased, consistent, and then sufficient statistic, and then complete statistic that also you need to go through. And then there is interval estimation. So I have some questions here in my thing over interval estimation. And then there is hypothesis testing. So most of the hypothesis testing we have done in our previous classes. So that is that is important because hypothesis testing is kind of very confusing. Like you need to see the question very clearly, that when is given the mean is known and the sigma square is known, and then n is this, n is that. So for each and everything there are different formulae. There are different formulae for the degree of freedom, and if you go for the t statistic, and then there is different formula when sigma square is known, not known, and if known then it is equal or not. And if you have n like two sample, if you have n1 and n2, then these are equal or not. So there are like a lot many things to go through for this. So and then there is test for proportions also. So test for proportion, if you go through all these things, you will understand that one thing is very much related to other, and there is not so much of difference. But then it's still the study is very important. Okay, just a minute. So I think this is the whole syllabus, and the thing which is not covered in the, at least in the assignments I have done, is chi-square test for goodness of fit. So uh, one question we can do that on that also, because so chi-square test for goodness of it. So, goodness of it itself is saying what we want to do. So, what we want to do is that we are fitting any let's say any parameter. So, in the time of distribution fitting, let's say you have values and you are fitting any distribution. Then to check how good it is, we use this chi-square test. Okay. So. With the question, I think we can. So this is nothing but we find this W or W star, whatsoever you want to say. So this is OI minus EI cap whole square divided by EI. So this is what, this is the expected one, this is the original one. So you have some data, you have some observed data, so original observed. So you have some observed data, so this is the observed one, this is the expected one, and this is the expected one. Let's say you are tossing a die. So in tossing a die, and you are calculating this number of 6 5 4 3 2 1. So for expected frequency, if it is always 1 by 6 1 by 6 1 by 6 expected probability, let's say if you are taking the probability terms, it is always 1 by 6 1 by 6 1 by 6. So if you are tossing a die 60 times, your expected frequency is 10 10 10 10 10. But in the real life it does not happen. So what may happen is that one is coming 12 times, two is coming three times, and maybe let's say three is coming seven times. So summation, overall summation would obviously be 60. But then uh, this may happen that your die is we will not say this die is unbiased directly, right? Because 60 is not a very large number of sample, let's say. But if you, let's say, toss a die 2000 times, right? and then it would be almost equal, the number would be almost equal of getting 1 2 3 4 5 6. It will not be like 1 by 6, but it would be around 1 by 6. So the more you increase your number of sample, the more you will observed frequency would be equal to the expected frequency. So that is the goodness of it, basically, that how good your sample is, that it is uh, mm, that expected one is the observed one, right? So if you have the question on this, then let's say in okay, so let's say this, we can make this question. So let's say you are tossing a die. Okay, let's say you are tossing a die 60 times. Okay, and then I'm saying the observed one will be like 1 2 3 4 5 6. Okay, so let's say I have observed that it came as 12, it came as 10, and then it came as 9, it came as 11, and then it came as 7, and then 7, and then 20 would be 30, right? So its summation would be, I think, 60. So this is our this one is our observed frequency, right? And expected one is uh, 10, 10, 10, 10, 10, 10, because this is how we say this, like all the time same, because it is unbiased dye we are taking. Then the W will be what, in the summation it would come as EI. So EI is nothing but 10, and over here you have a summation of OI minus EI square, right? So then you can do OI minus EI. So 2 square, and then 2 square, and then 1 square 1, and then 3 and 3 square. So that summation, and then you take the chi-square value at the point k minus 1. So you have here 6, right? So 6 minus 1 would be 5, and then whatsoever your confidence interval. So then we check this value. So if this W is less than this value, then we say this die is unbiased. If it is greater than this, then we say this die is biased. Okay, so this is the goodness of it. Okay, so I think this is the thing. Do we have anything else? Yeah, then there is a correlation coefficient. So correlation coefficient, basically when you have two let's say two variables, then how much it is correlated. So that then at that point of time you find this correlation coefficient, and then there is different correlation coefficient. There is Spearman correlation coefficient, there is Kendall-Star correlation coefficient. So, and I think this is the last. So we can have some questions. Let's see. So this is I have taken from the class itself. So basically, this is the thing. When you have this H naught and H1 is given, If you want me to tell you about anything else, like focus on any other topic, then you can tell me. Otherwise, we are going through the questions. I have some questions. So this one is h1 is lambda is equal to 5 and k1 is lambda is equal to 4, right? So now you can see that this lambda uh, is equal to 5, this one is 4. Then the thing here is that we reject the null hypothesis. We reject the null hypothesis when 2 summation xi is uh, greater than or equal to this chi square 2n comma alpha, right? So this we will have 2 summation xi, sorry, 2 into this lambda. So 2 into this lambda summation xi. So it is 10 summation xi greater than or equal to chi square, and then it would be sample size is 10, so 20 comma alpha. So this is the answer here. But if you go through the same question here, then you if you take the first one, like 2 summation xi, because what I have told you, 2 summation 2 lambda summation xi greater than or equal to chi square 2n comma alpha, then it would be wrong here. This is not correct. Why? Because here you can see lambda is equal to 5 and lambda is equal to 4, so this lambda is less than lambda naught. Let's say lambda naught is h naught value, right? So, but here this theta is greater than theta naught, right? So, here the hypothesis testing is different. Okay, hypothesis testing is kind of reversed. So h1 there was k1, so then you need to revise then which one is greater and which one is smaller. So now this time we reject the null hypothesis when 2 lambda summation xi is not greater than, it is less than or equal to this chi square 2n 1 minus alpha. So this would be the correct answer. So that also, like, there, see, there is very minor difference between the first and this question we have done, but the results are different. Okay, so that also you need to see that what is the, like, very specifically you need to see what is question, like what is h1, what is k1, and then what is whether it is greater or less. Okay. And then this question I think we have solved in the previous class. So let me just see where. Okay. Okay. Yeah, like this one. So this is same, just in place of 225, the 625 is given. So the answer would be uh, changed. So if you go through this question, then you can solve the current question also. Right. So this is the whole question is same. Just the values are different. Okay. So next question is UMVUE. So this is I think uniform minimum variance unbiased estimator. Okay. So this is how we say it. And then this one is one to third question. So third question. Okay. So this is how we find is that we find firstly the likelihood estimator, and then Uh, okay, so firstly, let's just find the likelihood estimator. So the likelihood estimator would be what? Uh, Multiplication, and then over, let's say just multiplication over alpha to the power c gamma c x to the power c minus 1 e to the power minus xi upon alpha, right? So if you do the multiplication over here, it would be gamma alpha to the power c whole to the power n, and then it would be summation, sorry, multiplication over xi to the power c minus 1, and uh, in E, it is summation over xi by alpha, right? So now, uh, like, I'm not gonna prove how we are coming at this, but summation xi given here is complete and sufficient statistic. So uh, there is not enough time to explain what is complete and sufficient, but then I have explained it earlier in the lectures. I think lecture 10 in the week 10. If you go through the week 10, then I have explained it how you have find know this is complete or sufficient. So summation xi is here a complete and sufficient statistic for alpha. Then we have expectation of summation xi, and then it's an alpha c. So of course there is so much of calculation involved here. So some expectation of summation xi over nc is nothing but alpha. So when you will do it on your own, you will understand it, I think. So this is nothing but x bar upon c. So this is the answer. Now the next question here is also like UMUVE. So either we can go through this question, or like it would be better if we go through the question which has more chance to come in the question. So this is nothing but you need to find like x and you knew. So let me just write it. So y is equal to x1 you can take, and then z is equal to x and you can take, right? And then yeah, so there is one thing also you need to remember is order statistic. So order statistics also I have explained earlier, I think. Like, then order statistic means you have xi xn. So then there is a different fxk. So fx pdf is different from fxk pdf, and then order statistic give fxk pdf. So I would recommend you to go through this, uh, this one. So it would be better for you if you go through this one. This very clearly written everything. So formula given here is that this is for the cdf of xr, and this is for the pdf of xr. How you find this pdf and then cdf, and then like let's say my data is like sorry my data is, let's say the x is following this exponential. So exponential, you know what is density function of exponential, what is cdf of exponential, and then you can put this value here, and then you can find the answer, right? So this and this one is for xn, and x1 is this is the special case, of course, when n is equal r is equal to 1 and n. So then you can find this fx1 fxn. And then for some distributions, the solving is also given, so then you can go through. And it may also happen that this f of uk, let's say uniform distribution, so it is following beta, and it may also happen that it is some arbitrary distribution, so it is not very important, then it will follow always some kind of distribution. It may happen then this pdf is arbitrary means you have you don't know, you have not given any kind of name it before. So then you can go through these all these things. So this is for the order statistic, right? So then we can write here the order is statistic, and then we can find the expectation of that. And because let's see, this is given in the term of order is statistic, so then you can find let's say you have x and y here. So now you can find the expectation of y, right? Because you know the pdf and you know the y, then you can find the expectation of z, and then you can find sorry, expectation of like this, because it is given in terms of ny minus z or nz minus y, right? So then you can find this expectation ny minus z, expectation of nz minus y, and then you can see which one is the UMUVE. So I'm telling you the answer is A, but then you need to solve it on your own. Okay. And then this question like is from interval estimation. So what is given here is that the population of a score of 10-year-old children is uh, in the psychological performance test is known to have no normal distribution, and then sigma given here is 4.7, and n given here is 15, right? And this mean, this is mean, this was just cut, there was some cut. So mean given here is 17.3, and then you need to find the 95% confidence interval. So 95% confidence interval, how would you find? You can find by using statistic, and then it would be 17.3 minus this sigma upon root n, so 4.5 divided by root 15 times this z uh, alpha by 2, and then 17.3 plus 4.7 divided by root 15 into z alpha by 2. So now you need to know what is z alpha by 2. So z at 0.005, because 95% confidence interval is given. So then you put the value, and then you will have the answer. So the answer is, I think, this one. Okay. So then you can solve it. And then there is this question. So this is kind of very lengthy if you solve, so I'm not going to solve it, but I can tell you how to solve this, so you can do the calculation on your own. It's from the 11. Okay. So what we are saying is that we have given one null hypothesis, and then we are rejecting the h naught if x is less than or equal to k or x is greater than or equal to p. So uh, type 1 error we need to find. So type 1 error is what? Type 1 error, uh, if you don't remember, I can tell you, is this probability of rejecting h naught when h naught is true, right? So rejecting h naught means rejection reason is what? X is less than or equal to a, or x is greater than or equal to b, given h naught is true means p is equal to 0.5. So when x is so this and these are two separate things, so we can find it x is less than or equal to a. So x is less than or equal to a means 1 minus probability x is greater than a. Now x is greater than a means uh, 1 minus probability x is equal to because this is the discrete one, right? So x plus 1, a plus 1, and then x is equal to a plus 2 and up to infinity, right? Now the probability that x is equal to a plus 1 is nothing but 1 by 2. This p is 1 by 2, 1 minus 1 by 2, and a is this would be a plus 1. So nothing but 1 by 2 to the power. Okay, so let me just write it. So when k is equal to a plus 1, it would be 1 by 2 and then 1 by 2 to the power a plus 1. So it would be 1 by 2 to the power a plus 2. So it would be a plus 2, and then for it would be a plus 3, and then so now you know this is a series. So it would be uh, 1 minus 1 by 2 to the power a plus 2, and then it is infinite series, so it is a upon 1 minus r, right? So 1 minus 1 by 2, 1 by 2, and then it would be cancelled out, so it would be 1 minus 1 upon 2 to the power a plus 1. So similarly you can find for the b, and then you will have this summation, right? So the answer is D, right? So up to this we are doing, and then if you have any doubt you can ask me, and otherwise we will end this class here, and thank you for the joining. Okay, so okay, right.